Hello friends, welcome to our channel The Mechanical Engineers Theme. I'm Jagdish Perk Associate. Today's topic is GATE. So in GATE we are going to see a thermodynamics numerical problem which was appeared in the GATE paper 2002. Before going to this video, please press the subscribe button of our channel The Mechanical Engineers Theme and also click the bell icon so that you will get the notifications for new videos. So first I will read the question. A carnot cycle is having an efficiency of 0.75. If the temperature of the high temperature reservoir is 727 degrees Celsius, what is the temperature of low temperature reservoir? Option A 23 degrees Celsius, option B minus 23 degrees Celsius, option C 0 degrees Celsius, option D 250 degrees Celsius. Now I will analyze the question. There is a heat engine. You can see here the picture of the heat engine. The working principle of this heat engine is Carnot cycle. According to the working principle of Carnot cycle, the heat engine will receive heat from the source. And by using the heat from the source, the heat engine will produce some work output. But all the heat from the source will not be converted to work output. Some of the heat will be rejected to the sink. Okay. So here, the source is the high temperature reservoir and sink is the low temperature reservoir. So in this question, the temperature of the high temperature reservoir or the temperature of the source is 727 degrees Celsius and the efficiency of the heat engine is 0.75. So in this question, we have to find the value of the temperature of low temperature reservoir or the temperature of sink is whether 23 degrees Celsius or minus 23 degrees Celsius or 0 degrees Celsius or 250 degrees Celsius. Now I will list out the given conditions. First, Carnot efficiency or the efficiency of heat engine, which is 0.75 and it is taken as neta. Next is temperature of source or the temperature of high temperature reservoir, which is 727 degrees Celsius and it is taken as T1. Here the temperature is in degrees Celsius. We will convert it to Kelvin. So just add 273 with 727 degrees Celsius. We get 273 plus 727 degrees Celsius is 1000 Kelvin. So the temperature of source is 1000 Kelvin. Okay. Next is solving technique. We know that Carnot efficiency, the temperature of high temperature reservoir and the temperature of low temperature reservoir is related by the Carnot efficiency formulae, and the formula is neta is equal to 1 minus T2 by T1, where neta is Carnot efficiency, T1 is temperature of high temperature reservoir and T2 is temperature of low temperature reservoir. We know the values of neta and T1, so we can easily find the value of T2. So just substitute the values of neta and T1. We get 0.75 is equal to 1 minus T2 by 1000 Kelvin. Now bring this T2 by 1000 Kelvin to the LHS and move this 0.75 to the RHS. We get T2 by 1000 Kelvin is equal to 1 minus 0.75. Here 1 minus 0.75 is 0.25. Therefore T2 by 1000 Kelvin is equal to 0.25. Now move this 1000 Kelvin to the RHS. We get T2 is equal to 1000 Kelvin into 0.25. Here 1000 Kelvin into 0.25 is 250 Kelvin. So T2 is 250 Kelvin. Now we will represent this temperature of low temperature reservoir in degrees Celsius. For that, just subtract 273 with 250 Kelvin. Okay, so T2 is equal to 250 Kelvin minus 273. So 250 Kelvin minus 273 is minus 23 degrees Celsius. So the temperature of low temperature reservoir is minus 23 degrees Celsius. So the solution for this question is B is the right answer. You can see here among these four options, B holds the value of minus 23 degrees Celsius, which is the temperature of low temperature reservoir is minus 23 degrees Celsius. So this brings an end to the explanation part of this question. I hope you all would have understood. If any doubts are there, please do comment in comment box. And remember to like, share and comment on our videos. Thank you friends.